Hamnene kudlukula nyepangira galagena nyephamnene kudlukula ibuloke nongoto ndibeti sola ibuloke dato
Fiki Congo
Lamin
na
Lamin te jibe norin te nyame Lamin
kabana
wulo ko no nyinta mo Lamin
pabilenki
muna ngata afamole
haina
ngata ngoto le Fabrama
mingi baba nyole
ngoto le Fabrama
namu jumala kan kuma diten
Fabrama
jumala mu
ndele bare muso
lunda mana
mo kata
jamani mbere
alindo ko
jamani
bari ngoto man kontande
bari jamani fana na rabudu ma kontan
ngoto minaka ngalamin de fom filitala lamin jibe nori nyaala
lamin ila siran sama ne benki yala so tol sayndi no ko mo lakko momo
ngoto
nam
itedinte alo ne lamin hakkilo diata bake karambu ngoto anu santen ministry ko di ngole si suko na amanke ko do holi
sibitun
bagona de
ala ni ko kede no mo balo
ala ni na ko ina karta bulo be damen ala ni je
ngoto
nam
ngoto man kontan feren
jamani mu nekata
ite ka lamin ki wulo ko no nyinta mon ko do fete malo lamin nyanta sila la be la moy kala karango
jamani karamol be soron ne ko fasita wulo ko nako
karambu wol ma soron ni ko karambu wol soron da amanke ko holiday lem ngoto dini wonyanta sila la ala karango la moy yamen kamen fue man kontan anda mande
alla nyin kombo courant adanda la kombo len do la jankara mol le soron do kamen courant ma rado la kombo e ko ndol fana na kara mol soron je kara mol soron lamin ada lo nyino la amanta ra fena so kon ala mu nekela
am lamin ite foyde malon kon le sinol be ke kar radio to
nga fine
e ko yana di mod lamin ya mu na fonye
bir kabin mina kan tambita nteri maning fatu tambide la sugal ala dinol bebe siri be la moy ka
faru danso am fana tambira jele ni subala la ngaje dini ngol be jet talanta nin kili warol e be serin jele
sa lamin fadante ku kili wo ke no la ba lamin bi taka wulo ko no nyin taymo alamin
amandara fenela
ite dine ko di man si yakari la suno la moy radio to e balon na
muneka ke afonye ba nyara ni alon
telentel jikot
afonye ba mu be ke
ite balon tel be jikiritel ni man karam ku kele yaaje nata karana mbasa malaya e tarije
par ñarande kombo courant ho findira kombo ide nara yede ni sonka bay ko lamin manya tala wulo ko karam mo be so da fa nyembe be kala
ko to wole nati bawo ngalle ni lamin kuntal kombo courant o ka fa me kombo courant asototal wala kinay ko e sisu ko no bari ni ko e sisu ko no ibe karangol dike la radio ni telel to ani tele masoto to nyaay man tele soto la bungo bar radio be bulen ko to batiri sanga ay si ay alamo
sa do kala nyaadi
ko ta o bulaji
abe kala nyaadi
kamun ke nyaadi
radio abe wala mo la ibe mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ga karam
baby jele baby jele
wala nan ka chocho moy fa dan se wolya ngombe tambi kana ngadi ngol je be ikadum bungo ko kala ma mo
asototal de
la min mala be karawala de
bari laftala ideal on ko inde every year second wala fourth
muna ni ko di ko nde ko felle sini lamba ndele sini lo ne ba
say mba foke en koto wole fango yen wulindi bat yu fanam bulata ko ko me yen nati jambi lamin nyanta karana ndel be jiko be nyineka ya bulay kara wulo kana ta kilar ya bambalo yo be bulaje koto dinni ngoy si ayala le sino la moy radio
wala ga munda kara mo man soro lamin nyanta kara si so na be
la sila le ayala le sino
ndani ko korna ko smolon
kilar ya
be ngela ko momo ni fano kera
mengi bruzo
ndebe ko do la da baro sa no re no dieje abe jele ba ngamra do man nembe buljan dala nyara ni arwo ko fendi mo la ban tayra ba do sa
bara te ku folo ajibe nori nya labi tamete ku
mengi mun na re
teku
bari ko do famo ke
ja image nani nyambol si se wolle ke je kisigi man si se wol no le kafun ka nyoma bari nyambu kino li manya na ka fendi ni nambe ko do so la ga
ta de be nyambo do dilanna
nyara ni ko rim fennat nyara nata
koto bari famo kada
ngata bungono tammi bungono nyara mel ngando ko fele ko ke e baru nganda ni pelo la ndija
iyo awa be tar la
bungono bismillah bisu diara
pendulala ye fongo tanka sina dolu tanka koro korota korota
Good day, viewers and listeners. Welcome back to my physics class. I am Miss Cham, and today's lesson will be uniform circular motion. And displayed on the screen are the subtopics that we'll be dealing with. Before we go further, I would like to discuss the types of motions we have. There are many, but then on the board will be few listed types of motions. And the first one there is the translational motion, translational or linear motion. The second type is circular motion. And the other example of motion we have is oscillatory motion. Today's focus will be on circular motion. And when we talk about circular motion, it simply refers to the motion of an object towards a path, right? And when an object moves around a circular path, these are the things that happens. The first thing you need to note is that the circle at which it moves, or around the circular path, you must have a uniform or constant radius. And this tells you that the radius of that circular path wouldn't change throughout the motion. Constant radius must be present. And two, the object's velocity changes from one point to another. When I say the velocity changes, I'm referring to the direction, right? The direction will always change, which is the magnitude of the velocity, will always be constant. The magnitude of the velocity, which we call speed, will always be constant. These are the 3 points that you need to know. When an object moves around a circular path, it has a constant radius, and then the magnitude of the velocity changes from one point to another, but then the magnitude or the speed of the velocity will always be constant. Some of you might be thinking or saying, how is it possible for an object to accelerate when the velocity is just changing, or when the velocity is just constant? This is simple, right? The magnitude of the velocity wouldn't change, but then the direction will always change from one point to another. Let's just take an example here. Let's assume this is an object moving around. Now at point A, you will notice that the velocity will point towards the right, but then the magnitude of the velocity at any instant will be the same. If the object comes to point B, the velocity will point to the left, but then the magnitude will always be 3 meters per second. This is why I said when an object moves around a circular path, it will always accelerate. And this is true because the magnitude of the velocity will be the same, but then the direction changes. And also, the radius of that circular path will always be constant. Is that understood? Good. Now, example of uniform circular motion include an automobile trying to negotiate a curve, or maybe the rotation of the Earth, or satellites moving in their orbit. These are all examples of uniform circular motion, and they are all displayed on the screen. Okay. Now, for an object to move in a circular path as well, you should know that the object has to be a rigid body. And when I say a rigid body, it means that the object's body shape wouldn't. It can fall, it can be displaced, but then the shape will remain intact. It wouldn't change at any point in time. Is that understood? And then there must be a center of rotation, and that center of rotation wouldn't be varied. Wherever the object is, the direction of acceleration will always be towards that center of rotation. Is that understood? And this is true because the object's shape and size wouldn't change over time. Good. Now, when we talk about uniform circular motion, these are some of the terms that you expect to hear. And these are the angular displacement, which is denoted as theta, and it is a vector quantity which is measured in radian, but then it can also be measured in degrees, in circles, or in revolutions. Now, when an object moves around a circle, I'll draw that part again. You will observe that it has a radius r, which is the same throughout its motion, and it will now sweep an angle theta. And when the object goes around the circle as well, let's say it moves from point A then to B, and back to point A. It has undergone a single revolution. And then when an object undergoes a single revolution or one revolution, it covers a distance called the angular displacement, which is defined as the ratio of the circumference to that of the radius of that circular part. The radius of that circular part. In short, we know as it moves in an anti-clockwise direction, as the object moves from point A, then goes to B and back to A, it covers one cycle, and then the distance covered at that cycle is what we call the angular displacement. As theta, and it is also mathematically expressed as the circumference of the circular part all over the radius of the circle, and that should be S all over R. And from your geometry class or from your math classes, you've noticed that the circumference of a circle is just given as 2 pi times the radius. And therefore, the angular displacement, which we defined as S over R, will be 2 pi times R all over the radius. Simplified will give us theta equals 2 pi, since the radius will cancel. But like I said, that moves from A to B and it covers one complete cycle, and the total angles in a cycle is just 360. So as the object covers an angular displacement of 2 pi, it also covers an angle of 360 degrees within a single revolution. So to relate what I just explained mathematically, we will have something like theta equals to 2 pi. That was when I started, but again, as it moves around the circle, you are told that the angle it covers will be 360 degrees, and when that angle is covered, we are told that a complete revolution is also obtained. So this simply means theta is equals to 2 pi, which is also equivalent to 360 degrees, and at the same time, theta will be one revolution or one cycle. Is that understood? Now I said the SI unit of theta, which is angular displacement, is radian, which is abbreviated as rad. Can also be expressed in degree, cycle, or how to call it, revolution. Now to convert from one unit to the other, we're going to use this simple logic here, which is theta equals to 2 pi, which is equivalent to 360 degrees, equivalent to or one cycle. To convert from one unit of angular displacement to the other, we use this above expression. If you're a good science student, you should know that you cannot obtain 2 or more equal signs in one problem. So this can be simplified as theta equals to 2 pi, or 2 pi equivalent to 360, or 360 degrees is equivalent to 1 revolution. So if you're asked to convert from one unit to the other, this is what I expect you to do. Good. There's a problem given to us on the board, and it reads, determine the angular displacement in radian when a car moves through a roundabout of distance 10 meters and radius 2.5. Now let us note what is given there. We are given the distance around which the object moves, and that distance is simply called the circumference, and we can denote it as S. The distance, which is the circumference, is given as 10 meters. The radius of that circular part is, what's the radius again? 2.5 meters. And the question says the angular displacement in radian. So this tells us that theta will be S all over R, but then S is already given, and that should be 10 divided by 2.5. You will notice that M over M will cancel, and then some of you might be thinking the angular displacement doesn't have a unit. Since it's the ratio of 2, that radian. It is widely adapted because we don't want to refer to angular displacement as a unitless quantity. That is why we said the unit will be radian. Is that understood? Whenever the two M's cancel, you are no longer left with any other unit but then the radian, which we call the rad. So this simplified will give us 2 radians. Clear? question. And question 2 says, we express the following angles to radian and revolution. Remember I told you we can always convert from one unit to the other. And here the unit given is degree, that is 360 degree. You don't even need to calculate this. You should be able to express it in terms of and revolution or cycles. Because I told you that if you go around a circle once, you've made a complete revolution. And in doing so, you've undergone an angle of 360 degrees, which is also 2 pi. So the first part of that question is simple. 360 degrees will just give us 2 radians or 1 revolution. That's the A part of question 2. And the second one given there, B, is 40 degrees. We are asked to convert 40 degrees to radian and to revolution. Now the first thing you will do is to write the relationship down. We know theta is, which is also equivalent to 1 revolution. Now we want to start with radian, right? So it means, and the angle given here is 40. So we will write theta, which is equivalent to 2 pi radians, is given as 40, but then we don't know what it is in radians. We call it an x. But what's the angle given there? It is given as 40, and we know that 306 will give us 2 pi radians. So here we cross multiply, and this will be 360 times x is equivalent to 2 pi times 40. We can cancel the zeros, 0 cancels, and this gives us 36x is equivalent to 2 pi times 4, and that should be 8 pi. We want to make x the subject, so we divide everything by 36, and that gives us 36x divided by 36 is equivalent to 8 pi all over 36. So x is equivalent to 8 pi all over 36. You have your calculator, so you can just simplify that. But then x was under the radian column, so it means your answer will be 8 pi divided by 36 radians. So whenever you have to convert 40 degrees to radians, that's what you will obtain. Have I communicated? We move on to the second one, which says we convert that to revolution. Again, we know that 2 pi radians gives us 1 revolution. How many radians have we covered? That was 8 pi all over 36 radians. And then what will that be in revolutions? We don't know. So we cross multiply again, and this 2 pi x is equivalent to 8 pi all over 36. Okay, we've written this down, but someone said the answer to that 8 pi over 36 is the same as 0.698 radians. But then what is it equivalent to in revolutions? We call it x since we don't know. So we cross multiply, and this will be 2 equivalent to 0.698 times 1, which is just 0.698 revolution. We divide both sides by 2 pi. 2 pi will cancel, and x becomes 0.698 divided by 2 pi. That is 0.111 revolution. You see how simple this is? We move on to this letter C of this question, and that says we convert 180 degrees to radian and then to revolution. So we always start with radian. What do we know? We know that 2 pi rads is equivalent to 360 degrees. But what angle is given? That's 180. What is it equivalent to in radian? We don't know. We call it x. So here we cross multiply again. And this gives us 360 times x, which is 360x, is equivalent to 180 times 2 radian, 2 pi radian. That should be 180 times 2 is 306 pi. 360 is common. It is on both sides of the equation, so we just cancel them out. And this gives us x is equivalent to pi. So x is equivalent to pi radian, and we all know that pi is 3.142 radians. So 180 degree is the same as 3.142 radian. Then we move on to converting 180 degree to revolution. Okay, we know that 360 degree gives us 1 revolution. What angle is given? 180 degree is equivalent to x number of revolutions. So we cross multiply, and this will be 360 times x equivalent to 180 times 1. We make by dividing everything by 360, and x 180 all over 360. And this should be half. Therefore, 180 degrees is equivalent to half a revolution. Is that understood? Good. But then before we conclude or we continue to the next slide, I would like to relate S, theta, and R. Note that we said theta, which is the angular displacement, is just given as S all over R, where S is the linear distance or the circumference, R is the radius of the circular part, and theta is the angular displacement. From here, we can simply say equivalent to theta times R. So this is how we relate angular displacement to linear displacement. So if ever you are asked in your test or exam to establish a relationship between angular and linear displacement, this is clear? Good. Okay, there's another problem on the board, and it reads, what is the angle inside a circle in radians that subtends an arc length of 0.25 meters? The radius of the circle is 5 meters. Now we are given the arc length, which is the same as the circumference of the circular part, and it is 0.25 meters. The radius of the circular part is also given as 5 meters. But then the question says we determine the angular displacement in radian, that is theta. So theta equals to S over R. You just substitute the values into the equation and obtain your answer. Now option A reads 0.01 radian, B reads 0.03 radian, and option C says 0.05 rads, D says 0.08 radians. The correct option should be letter C. Question 2. What is the value of pi over 2 radians in degree? That's a nice question. You just use the relationship we established earlier on, which says 2 pi radian is equivalent to 360 degree. And then write down what is given. 360 degree is equivalent to 2 pi radian. But the question says, what is the value of pi over 2 radian? It should be under the 2 pi radian. What is it equivalent to in degree? We don't know. We give it a question mark. But pi over 2 is the same as 0.5 pi. So we just cross multiply, and this will be 360 times 0.5 pi is equivalent to 2 pi times x. Pi is on both sides of the equation. We can just cancel it out. Pi cancels pi. We are left with 360 times 0.5. And that should be 180. So that's 180 is equivalent to 2x. It's x that is required. So we divide both sides by 2. And our answer should be x equals to 90 degrees. Now option A says 0 degree. Option B 45 degrees. C says 90 degrees. And option D reads 180 degrees. The correct C, which is 90 degrees. Okay, that one is very simple, similar to the first question. I'll just read out the question and the options. You try answering them. It says, what is the angular displacement for an arc length that is equal to the radius of the circular rigid body? Good. I think I should help. I never, but it's a bit challenging. Now you're told that the arc length S is equivalent to the radius. We assume they're equal. So what happens if theta is just S over R, but again we are told that S is equivalent to R. Let's assume S is 1 and R is 1. So 1 divided by 1 will be 1. Divide two equal values, the answer must always be 1. But remember, I told you if the units cancel, the resulting SI unit will be radian. Now the options are A, 0.5, that is not true, and B says 1.0 radian, and C says 0.5 pi radian, and option D reads 1.0 pi radian. The correct option to this problem is letter B, which says 1.0 radian because the units cancel. Okay, let's move on to the second term, which talks about the angular velocity. Angular velocity. It is denoted as omega, which is a Greek letter. And if you've studied linear motion, you should know that these terms always follow each other. Whenever we mention displacement, velocity follows. And from velocity, you expect to hear the word acceleration. So nothing changes. We're no longer dealing with linear motion or translational motion, but circular motion. But the pattern in which the terms follow each other wouldn't change. Angular velocity is denoted as omega, and it is defined as the rate of change of angular displacement. So that means omega is equivalent to the rate of change of angular displacement. In physics or science generally, whenever we talk about rate, it means time must be involved. Is that understood? First must be written at the top and time comes to the bottom because we are referring to as the rate of change of something. And when a change occurs, it means, it started somewhere and ended somewhere. Is that understood? This is why we have change. And when I say change in angular displacement, it just means the final displacement, angular displacement, minus the initial displacement at t naught minus t final. Now we're going to assume that at t naught equals to 0, the angular displacement is also 0. And when that happens, the equation becomes omega equals theta minus 0 all over t minus 0. And theta minus 0 gives us theta, t minus 0 gives us t. The angular velocity will be theta all over t. That's very important. This is the first equation of angular velocity that you've just seen, but then there exist other equations of it. Clear? Good. Now we will recall that earlier on we defined angular displacement as S all over R. So this has to be substituted into the equation, and if that is done, we'll have omega R's theta all over, this is theta divided by t, where S all over divided by t all over 1. So rearranging this gives us omega equals to S all over times 1 all over t. We can further rearrange this to obtain omega R's S over t times 1 all over R. Easy for us. Remember, just the distance or the linear displacement, and t is the time.